MS Ramaiah University of Applied Sciences.
Hi students, name of the experiment is verification and interpretation of the logic gates. Aim of the experiment is to verify and interpret the basic gates like OR gate, AND gate, NOT gate and universal gate. Apparatus required for this experiment is digital IC trainer kit. So here you can see the digital IC trainer kit on which we are going to perform the experiment, and here you can, at the top you can see the various knobs. The knobs which is there in the black color are used for the inputs, and the knobs which is there in the red color are used for the output, and the inputs are controlled by this toggle switch, and if the toggle switch position at the top, it represents logic high, and if the toggle switch button is at the lower position, then it is represents the logic low. As well as the red knobs, you can see the LED bulbs on the every red knob where you can connect the output, and if the LED bulb is on, it represents the output is logic high, and if LED bulb is off, then it represents the output is logic low. At the middle you can see there are 4 IC bases, 1, 2, 3, 4. So each IC base is used to place an IC, and each IC base you can see here, it consists of 16 slots, 8 at the left side and remaining 8 at the right side. Each slot is internally connected to the notch shown here. So that means the first slot is connected to the notch number 1, the second slot is connected to notch number 2, and it continues in the same way. So therefore we can place an IC consists of 16 pins into this particular base, and also it consists of 2 pins, one is red and one is black, and this red pin indicates 5 volt DC with respect to ground. In order to give a power supply to the IC, we are going to connect red pin as well as black pin, which gives a power supply to the IC. In order to verify the basic gates, we can use any one of the IC base out of these 4. Here you can see the 2 knobs which is used to check the continuity of the patch cords. IC, so this is a 7432 IC which is used in this experiment, and it consists of 4 DL inputs, OR gates and patch cords. So these are the patch cords which we are going to use to connect the circuit. So let us start the experiment. So in order to verify the OR gate, let us take the 7432 IC. So here is the 7432 IC which represents the OR gate. Here you can see a notch which is there at one terminal. While placing the IC into the IC base, make sure this notch should be in the upward direction. Before placing this IC into the IC base, make sure the lever of the IC base should be open, then place the IC properly inside and lock the lever. Make sure the IC is not coming out. 7432 IC consists of 14 pins, but the IC base consists of 16 slots. So now the IC slot is covered by only 14 pins, and the last 2 slots are remaining free. So now therefore the pin number 8 and pin number 9 should not be used in this experiment, as the slots are left free. As per the pin diagram, let us start the connections. So to connect the input, I am using a black patch cards, and to connect the outputs, I am using a red patch cards. Before giving the input and output pins to the IC, let us give the power supply to the IC. So here pin number 14 of this IC represents VCC. So here I am connecting this pin number 14 of the IC to the VCC, which gives 5 volt supply, and pin number 7 of the IC is given to the ground. As I told, pin number 8 and 9 are not in use since the slots are left free. So as per the pin diagram, pin number 1 and 2 are the inputs and 3 is the output. So let us connect the inputs and outputs for the first OR gate. Now pin number 1 is connected to the input knob somewhere here. Pin number 2 is also an input. It is connected to the one more input knob. Now pin number 3 is the output. I am using a red color patch card in order to differentiate the input and outputs. So now pin number 3 is connected to the output knobs anywhere at the top. Now similarly, according to the pin diagram, pin number 4 and 5 are the inputs. I am connecting the inputs to the input knobs. Now pin number 6 of the IC represents an output. I am using a red patch card to connect an output. Output should be connected at the top. So pin number 7 is been used for the ground, and pin number 8 is the output here. and 9, 10 are the inputs. I am connecting the inputs 9 to the input knob and 10 as the input and 8 as the output on the top. Similarly, pin number 12 and 13 are the inputs and pin number 11 is the output. Inputs I am connecting to the input knobs and output I am using red patch cord again and I am connecting to the output knobs. As 7432 IC consists of 4 OR gates, it consists of 4 outputs. All the 4 outputs are represented here. This is the output of the first OR gate, and this is for second OR gate, this is for third OR gate, and this is for fourth OR gate. Also, each OR gate consists of 2 inputs. So these 2 inputs represents the first OR gate, and these 2 are for the second OR gate, these 2 are for third OR gate, and these 2 are for fourth OR gate. Connections are done as per the circuit diagram. Now let us turn on the power supply to the IC trainer kit. The LED bulb on here indicates the IC trainer kit is powered up. As per the truth table, let us verify the OR gates. So now these 2 are the inputs for the first OR gate. So now these 2 pins are in the low position now. That means both are logic low, 0 0. When both the logics are 0 0, the output of the OR gate will be 0. That can be seen through the LED bulb here. So LED bulb is off. This indicates the output is logic low. When I make the input as 0 1, so then I have to make it 1. So now the output will be 1. So that you can see in the LED bulb, it is on. Now the next combination is the output is 1 0. So now I will make the input 1 0. So now it is 1 0, the output will be 1. And the last combination is both the inputs are high. So when I make both the inputs are high, the output will be high. That can be seen through the LED bulb. And this continues for all the OR gate, remaining OR gates. So now let us check for the second OR gate. So these 2 are the input pins for the second OR gate. So whenever the inputs are low, the output indicates 0. So that means it is logic low. So therefore the LED bulb is in off position. So whenever the input is 1, that means 0 1, so the output will be high. So in the same way, for the input 1 0, the output will be high. In the same way, for the input 1 1, the output will be 1. So this is for the second OR gate. In a similar way, we will check for the third OR gate. So when the inputs are 0 0, the output will be 0. That you can see here. When the input is 0 1, the output will be 1. And when the input is 1 0, the output will be 1. And for the inputs 1 1, the output will be 1. The similar way for the fourth OR gate, we will check. So now whenever the inputs are 0 0, the output will be 0. And whenever the input is 0 1, the output will be 1. And for the inputs 1 0, the output also will be 1. And for last, whenever the inputs are 1 1, the output will be 1. Similarly, the experiment can be conducted for the remaining gates, that is AND gate, OR gate, NOR gate, NAND gate and XOR gate. So this concludes the experiment.
At MSR UAS, we spark your imagination unlike any other.